Okay, so this is the third problem in the Thevenin problem series. So let's go ahead, write Thevenin number 3. Okay, let's start the writing the circuit. We have a resistance in an amount of 436 ohm, and then we have a diamond here. We have another resistor in an amount of 100 ohm. We have a voltage source right here in an amount of 200 volt. We will get to the diamond in just a little bit. Let's go ahead and complete this part of the circuit. And here is the open end terminals A and B. So the resistance on the top is 100 ohm. The resistance on this side is 50 ohm. The current that's going along this 50 ohm is what we call I sub naught. I naught. And this diamond has the I naught showing up here as 50 times I naught. So this diamond shows a dependent source. It's current dependent voltage source is what it is. Let's go ahead, write it out. This is the ground terminal right here. And this is node number 1. This is node number 2. Okay. This is node number 3 as given. Now what we recognize is, as we have also these mesh currents given I sub 1 and I sub 2, we realize that I naught is nothing but I sub 2. So that is good to notice. Let's go ahead and write this subheading, determination of Thevenin. Notice that the goal in this problem is to determine the Thevenin voltage Thevenin and Thevenin resistance Thevenin, and finally figure out the max power this circuit can deliver. If we consider the mesh number 1 and apply KVL along mesh number 1, what do we get is, notice that we're measuring the voltages, so we will say using Ohm's law 436, which is the resistance, times I sub 1 minus 50 I sub 2. What we have done is we have replaced I naught by I sub 2 as what it is, equals to 0. So this is a good thing to notice. All right. Now, if we go look at the mesh number 2, what we see is KVL in around mesh number 2 yields 50I2. Okay, again we have used I2, which is equal I naught in the diamond, plus 100 times I sub 2 from Ohm's law, plus 50I2, which is writing I2 because that's the current flowing through this leg, then minus 200 as we complete the mesh equals 0. We can divide everything here. Well, let's just say we have 50, 150, that's a 200 I2. We could divide, but this is clearly straightforward. 200 I2 is 200, meaning I sub 2 is 1 amp. Something good to notice. Now we can use this In the previous expression where we had 436 I1 minus 50 I2 equals 0. In other words, we have 436 I sub 1 is 50 I2 and I2 being 1 is equal to 50. Therefore, I sub 1 is 50 divided by 436. And so we're almost there to determine P-Thevenin. P-Thevenin is the same as PAB, which is 50 times I naught, because from Ohm's law we have resistance 50 and current I naught, also the same as 50 times I sub 2, and this is giving us P-Thevenin as 50 volt. So that's a done deal. And finding I sub 1, which we did just a little while ago, is to complete finding all the mesh currents. So that's good. But obviously, we do not really need to get I sub 1 just to get P-Thevenin. That is quite clear here. It's good to get, but we could also get by without getting I sub 1. Next, let's get the R-Thevenin, folks. So to do that, one easy way is to short circuit the open end. So our circuit would look like, once again, this is 436 ohm resistance, and we have what now? Diamond is what we have here. Hang on just a sec. It's a little bit messy here. So let's complete the drawing of this diamond. Minus on the top, plus on the bottom. This is 50 times I naught. What else? We have this fellow 100 ohm on the top. And down below we have the voltage source, plus and a minus. And we have this fellow 50 ohm here. Now, as I said, we will short circuit this open end, and this current is what we call the short circuit current, which is also the Norton current. Norton, following Professor Norton here. So as we look at this parallel combination of 50 ohm and the short circuit path, we quickly realize that the 50 ohm will have no current flowing through it. There is no competition between the resistance, 50 ohm or whatever ohm, with a shorted path which has no resistance by definition. So that will mean that this resistance will carry no electricity. Therefore, as we said, I naught for that current, we conclude I naught equals 0. I naught equals 0. So this is the logic here. If this I naught equals 0, what do you think is going to happen to the diamond that has a 50 I naught? It has no output, meaning the current dependent voltage source in an amount of 50 times 0, that's 0 voltage, means it is just like a shorted path. So we are looking at a parallel combination of 436 ohm and a shorted path, okay? Which means the 436 is out of the window. It's not going to matter. So our circuit is extremely simple at this point. This 436 ohm path is abundant, as electrons, as smart as they are, will see that it is not a useful path for them to go through. So ultimately we have ISC, the current that's flowing, 20 ohm here, a 20 volt, and 100 ohm. So So ISC is simply the ratio of 200 volt over 100 ohm giving amp. Therefore, ISC is 2 amp. Knowing VThevenin and ISC, we have the RThevenin determined. Uh, we might write the 436 ohm here on the top, but again, truth be told, it's as good as not being there. So RThevenin is VThevenin over ISC. And recalling that VThevenin is 50 volt, we have here 50 over 2, which is 25, of course. So many ohms. Therefore, RThevenin is 25 ohm. At this point, we have Thevenin resistance figured out. Let's continue. Find the Pmax, which is the max power the circuit can deliver, which is equal to VThevenin squared divided by 4RThevenin. And VThevenin is what now? 50. So 50 squared on the top. Down below we have 4 times RThevenin, which is 25. So 25 times 4 is 100 on the bottom. So by cancellation, we have Pmax equals 25 watt. So this is the max power the circuit can deliver. So the equivalent circuit we can draw for the given circuit will consist of the Thevenin voltage accompanied by the Thevenin resistance. Then we could hook up a load which in the best condition can draw 25 watt from this source. So this VThevenin is what we have as 50 volt. And RThevenin is 25 ohm. And to draw the max power, we will have the load also equal to 25 ohm. And that's the sec here. Okay. So this is 25 ohm. All right. So this is your load R sub L. This is RThevenin and VThevenin. Okay, after Leon Thevenin. So we got the job done. Hope you enjoyed it. Take care.